Welcome to Climate Reflections, the SRM360 Podcast, where we discuss sunlight reflection methods, or SRM, ideas to reduce the impacts of climate change by reflecting sunlight away from the Earth. I'm your host, Dr. Pete Irvine, and I'm a climate scientist who's studied SRM since 2009. SRM ideas have mostly been studied using computer models, but there have been a handful of outdoor experiments that are too small to have any climate impacts, but can help scientists better understand the potential effects of SRM. In early April 2024, a team of scientists from the University of Washington began one such experiment on the USS Hornet, a decommissioned World War II aircraft carrier turned maritime museum off the coast of Alameda, California. The experiment aimed to test sprayers that would loft tiny particles of sea salt into the sky. This is the second experiment of its kind to test an SRM approach known as Marine Cloud Brightening, or MCB.
That roar is not coming from a snow machine. Instead, the plume you see are tiny aerosol particles. It's the first technology in the country to test ways to brighten clouds in an effort to cool the globe.
Local opposition to the experiment followed news coverage, and the Alameda City Council paused the experiment in May 2024, citing health and environmental concerns. The City Council hired consultants to assess the project's safety, and those consultants concluded that the project posed no risk to the community. They also heard public comments in a meeting on June 4th, 2024 that lasted long into the night. Some members of the public expressed support for the study, like this local resident.
This is an issue that people are really passionate about, and we should be. This is our collective future that we're fighting for, and climate change is complex, and the science is complex. And I come here, I don't know the science, but what I do know is that this study is about better understanding it. This study is not about deploying something that's going to go beyond the bounds. This is about understanding the implications, the conversations around what that will look like, what the implications are. We need to do this research to better understand it. And there are lots of facets to the issue, but I want to isolate that and highlight and underline this is not about deployment. This is research to understand if we should deploy. Thank you.
Other local residents spoke out against the experiment in Alameda and against the idea of SRM more generally.
While this is a local decision, it has far-reaching consequences, which is evidenced by the number of comments received from not only outside of Alameda or outside of California, but from outside the United States. There are global climate justice dynamics at stake.
As Indigenous individuals, we are requesting that you rethink your decision that allows our sun and its light to be taken from us and our planet on any scale. Thank you.
In the end, the City Council decided the study could not proceed, at least for now. We'll return to that decision later in this episode, but this episode will focus on the idea behind that Alameda study, Marine Cloud Brightening, or MCB. We will explore how MCB could potentially work, how it might be used to provide localized cooling, and whether it might be scaled up to cool the planet, and how field experiments like the one in Alameda could contribute to our scientific understanding. First, what is MCB? Here's Jessica Wan, a PhD candidate at Scripps Institute of Oceanography at the University of California, San Diego, who has been using computer models to study the climate response to marine cloud brightening.
So marine cloud brightening, or MCB, is this idea that we could put little particles into the lower atmosphere, people have typically thought sea salt, in order to seed clouds and make them brighter. And when you make these clouds brighter, they reflect more sunlight back out to space, which would cool temperatures locally and potentially even globally.
So, MCB would brighten some clouds, but how would that work? And how do clouds form in the first place?
There's basically two things required for clouds to form, and that is, you need particles for clouds to form on, but you also need a lot of humidity.
That's Dr. Isabelle Steinke, an assistant professor in climate engineering at TU Delft, researching the impact that tiny aerosol particles have on the formation of clouds. Dr. Steinke helps explain how clouds are formed and which marine clouds MCB would target.
For a droplet to form, what you need is a cloud condensation nucleus, so a particle, but you also obviously need enough water vapor for that droplet to form. So which means that in very dry regions over the ocean, so for example in some parts near Australia, it would be really hard to maintain a cloud there. What we want to have is a cloud that forms over certain areas over the ocean and that also lives for a certain amount of time. So that means that it doesn't have a lot of dynamics and convection. So that's why stratiform clouds are a really good candidate for this type of brightening.
Marine stratocumulus clouds are low-lying clouds that form off the coasts of continents in the subtropics. Like Isabelle was saying, these clouds form in stable conditions with little convection, or mixing, compared to other clouds, such as the towering cumulonimbus clouds of thunderstorms. Jessica Wan tells us more about these clouds and why they're good targets for MCB.
A lot of those early modeling studies have focused on what we call the three main stratocumulus cloud decks in the world. These are really expansive, low-lying cloud decks kind of off the western side of many continents. So there's one off of the west coast of the United States, off the coast of California. There's one off the coast of South America, and there's another one off the coast of Africa. And these are these really big cloud decks that persist for a lot of the year. So since they exist for a lot of the year, it was thought that these would be the ideal regions to do this type of intervention. These cloud decks are low in the atmosphere, which makes them special because they would be more easily accessible if we went out via boat to put particles in these clouds. These low-lying clouds are also special because they persist for a lot of the year. And so when we think about marine cloud brightening, we want to modify existing clouds more so than we want to create new clouds. So you want to target regions with lots of clouds for a lot of the year.
Starting in the 1960s with the advent of satellite images, scientists noticed bright lines through ocean clouds. These ship tracks provide support for the idea that marine clouds could be brightened artificially.
Probably the most well-known natural analog for marine cloud brightening is what we call ship tracks, which are these bright features that are created in the paths of large shipping vehicles from sulfate particles they emit. Basically, their dirty ship fuel seeds these paths of bright clouds in the ocean.
So little lines, are actually not so little, kilometer-long lines following individual ships. And you can see this in the clouds. It shows up as brighter clouds if you're looking from a satellite, or even if you're an astronaut on the International Space Station, you can just look down on the Earth and actually see these lines in the clouds going back into individual ships.
That was Dr. Michael Diamond, an assistant professor at Florida State University's Department of Earth, Ocean, and Atmospheric Science. Michael's research focuses on the climate impacts of cloud-aerosol interactions.
Something I found was that if we do the statistics in a clever way, we're able to see on these regional spatial scales and climate timescales a substantial brightening effect in the clouds from shipping that we're doing by accident. So it convinced me that if we were to actually want to do this on purpose, we almost certainly could, at least in certain cloud types. So that to me meant that it was really important to then understand the follow-up to that of, if we could do this, should we, or would we actually want to?
Michael brings up a good point. Just because we could deploy MCB doesn't mean we should. MCB, like other SRM approaches, raises a host of difficult ethical and governance questions. However, MCB poses some distinct scientific and technical challenges that are unique to it. Isabelle Steinke and Michael Diamond walk us through some of those.
The devil really lies in the details here. So, for example, it starts really at the bottom. So, from creating the right spirit technology, for example, that's robust, that delivers us the right particle size distribution, for example, to understanding how those particles would actually get transported to cloud altitude, and then eventually what they actually would do at cloud altitude, and which kind of feedbacks they would initiate.
It's only certain types of clouds that we get this really clear signal in the present day. There are other cloud types and cloud types that cover more of an area of Earth where we're still not really sure what kind of effect we're going to get from having additional aerosol emissions. We also don't know if you brighten one patch of the ocean with aerosol emissions, will you have a damping effect on clouds in another part of the ocean? And this could really mess with Earth's circulation system. So, for example, a number of climate models have shown that if you were to intervene in the southeast Atlantic, off the western coast of Africa, and only there, you would set off a wave pattern in the atmosphere that would wind up decreasing precipitation over the Amazon. So if you tried to produce cooling there, maybe even to save the Amazon, you might get the exact opposite of what you want via that effect on precipitation. This tends to be blunted if you then seed other areas of the ocean, but each of those are setting off their own wave responses. So the question becomes, can we actually predict those wave responses well enough to understand what it's going to do to precipitation across these different parts of the globe? And if we could, can we actually target the clouds that exist in those different locations? So clouds might be susceptible in the Southeast Atlantic, but not in the Northeast Atlantic. But maybe you need both of those to not have that dangerous wave pattern arise.
Most of the scientific understanding of MCB is built on observations of ship tracks and other natural analogues, as well as on simulations and computer models. Both can provide crucial insights, and climate model simulations are essential for projecting the possible climate consequences of deploying MCB. However, model simulations and observations alone won't be sufficient to resolve the uncertainties around MCB. So let's talk about what value outdoor experiments add to SRM research, where these experiments have happened, and what they have aimed to achieve. First, we'll hear from Jessica Wans.
I'm a modeler. I love doing that type of research, but there's only so much we can learn from models. And really, if we're ever going to be in a situation where we feel confident implementing marine cloud brightening for climate risk mitigation, we're going to need outdoor field experiments, because models are not reality. We're not going to know what all those strange idiosyncrasies are when you think about real world weather, real world climate, unless we do these field experiments. And so there are kind of two main marine cloud brightening field experiments to date. The first one is that Australian Great Barrier Reef experiment that started in, I think, March of 2020, where they were testing this nozzles, the sprayer technology to generate the right size particles to alter clouds. And I think it's been ongoing since then. But really, they're just testing the technology to actually generate particles, not having any sort of big climate response.
The second experiment Jessica is referring to is the one in Alameda that we opened the episode with, and we'll get back to that in a moment, but first let's hear more about the work over the Great Barrier Reef. Dr. Daniel Harrison from the National Marine Science Centre of the Southern Cross University in New South Wales tells us what motivated his group's experiment and the broader efforts to protect the Great Barrier Reef.
What motivated us to start was the mass bleaching events that occurred in the summer of 2015, 2016 here in Australia. Prior to that, there'd been some historical bleaching on the Great Barrier Reef back in the late 90s and the early 2000s, but it was relatively sort of minor to moderate. In 2015, 2016 was when we had the first really large mass bleaching event on the Great Barrier Reef, and that motivated some of us that were sort of interested in human-caused problems to ecosystems to start looking into what could possibly be done to alleviate the heat stress. And so we didn't start with SRM as an idea. We started actually sort of looking at whether you could pump cold water up onto the reef and cool it down that way. And we started just looking into all sorts of different ideas of how we might be able to basically shade or cool corals. And that led us over a period of time to look at marine cloud brightening. And as we did the desktop research and the engineering sort of feasibility evaluations, the marine cloud brightening just kept rising to the top of the pile while others fell out.
Daniel's project is part of a larger effort to protect the Great Barrier Reef called the Reef Restoration and Adaptation Program, or RRAP, a large program established by the Australian government to investigate a broad range of ideas to support the survival of the Great Barrier Reef as the climate changes. Daniel leads the cooling and shading sub-program of this effort.
You could think of them as the sort of engineering ideas to help coral. So all of the cooling and shading type ideas. And so this covers everything from trying to pump cold water up onto the reef to cool corals down, through to ideas that shade the corals, like floating biofilms or artificial marine fog, and through to marine cloud brightening as one of the sort of larger scale ideas.
We'll hear more about RRAP from Daniel in an upcoming episode on field experiments. But for now, let's focus on the technological contribution. What has this work revealed about the technical feasibility of marine cloud brightening, and what are its limitations?
At the moment, the technology that we've developed are very regularly face the misconception that we've developed technology to go and do cloud brightening, and you pretty much can just take it and multiply we've got by as many stations as you think you'd need and go out and get started. That's very far from the case. The reality is that we've essentially built a testing apparatus, a system that allows us to atomize enough seawater to go and to start to look at how the clouds respond under different circumstances of meteorological conditions and different types of clouds and different atmospheric situations of background aerosols and atmospheric stability and all those kind of things. But it's really, I think of it as a big bit of laboratory apparatus that we're taking out into the real world. It's not a system to go and start doing cloud brightening. I think we're still a very long way from that. I think even to do an area as limited as the Great Barrier Reef, we need between a factor of 10 and 50 improvement to the current technology in terms of energy efficiency and droplet generation and quite a few factors before you could even start to think about a sort of actual implementation scenario. If you wanted to scale the technology, or you wanted to take the technology and do something at sort of globally relevant scales, which obviously a lot of people have thought about using marine cloud brightening in that context, it would be even a further factor of another 10 times that. So probably hundreds, if not thousands, of energy efficiency improvement required before that was really feasible. So we're still quite a long way from being ready to build equipment and go out and start doing cloud brightening.
That's the kind of technical or engineering side of feasibility. What's your research suggest about the scientific feasibility? If you had those sprayers that are 50 times as effective, are you confident that this would work?
I'm quite confident it would work, yes, because we know that quite overwhelmingly the net response to additional aerosols in the atmosphere is an increase in cloud radiative forcing and therefore a cooling of the surface. Again, there's quite a lot of devil in the details. That doesn't mean it would always work optimally under every situation, but we're quite confident that the response of the clouds is sort of quite significant and measurable, but then we're only looking at the initial response too so far. So that's the Toomey effect, the most well-known effect of cloud brightening, of changing the distribution of droplet sizes in the cloud from fewer larger droplets to more numerous smaller droplets, which are more effective at scattering light. However, those initial changes to the cloud physics, they then impact a whole subsequent range of atmospheric and cloud physics processes, which then evolve over time, over the lifetime of that cloud, and potentially even beyond that, if there's sufficient aerosols added to the system, that they're released back out of the cloud and then go through multiple rounds of cloud processing. So I think what we next need to start to understand beyond this project is how do those other sets, what's often known as the second indirect set of effects of aerosols, how do they play out when you add additional sea salt aerosols or cloud condensation nuclei under different scenarios? Because again, it's never the same atmosphere two times, right? So we have to sort of gain quite an understanding of under what types of atmospheric conditions it will work well and what types of atmospheric conditions it won't work well. And that's quite complex. But I think overall, we can be quite confident because overall the net effect of extra cloud condensation nuclei on clouds is quite a strong cooling effect.
The MCB experiment over the Great Barrier Reef is entering its 5th year, but the small-scale experiment in Alameda, California, that this episode opened with, barely started before it lost its permit. We were not able to speak with scientists associated with the project, but Jessica Wan, Isabelle Steinke, and Michael Diamond provided insights into the scope of the project in Alameda.
The University of Washington started this experiment in Alameda, California, to also test their own sprayer technology off of a ship. And again, that was just to test the technology, not have any large-scale influence on the climate.
So they had a device that they had constructed for spraying, and they wanted to use it to just test how well it would work, and whether it would produce the expected particle size distribution. So that was probably their primary goal. And another goal that they had was to engage with the public and to really have it in a more or less prominent site, right? So that would be easily accessible to the public. They did make some efforts to really engage with the local stakeholders.
They recently attempted to do some outdoor testing as part of an educational exhibit on the USS Hornet, which is a retired Navy ship that's now a science museum in Alameda, California. They had initial approvals to do that. The city, they did not really announce it much in the media, etc., until the field trials actually started. The city realized that the study was maybe had some bigger implications than they had realized just from the physical science aspects of it, which was relatively small tests of seawater spraying, and that led to some fights over permitting and ultimately the project being put on indefinite hiatus is the current status.
Public engagement is something that scientists often think about when designing studies like this, and the team from the University of Washington was no exception, conducting their experiment at a public museum. However, once the experiment started, the team faced opposition from residents and from a broad network of environmental activists from around the world, who oppose SRM generally. According to an NBC News report, a representative of the Center for International Environmental Law stated her organization, quote, was not worried about immediate impacts in Alameda, but rather the project would lay the groundwork for widespread manipulation of the climate, end quote. But as we heard Jessica Wan describe earlier, these experiments could also have a large value for climate science, advancing our understanding of aerosol cloud interactions. The Marine Cloud Brightening component of the Reef restoration project in Australia has not met with the same kind of opposition that other field experiments have faced. What is RRAP's approach to engagement and outreach? Here's Daniel Harrison.
Oh, where to start? It's big and there's a lot there. So broadly speaking, all of the Reef Restoration and Adaptation program is framed right from the very beginning around this mission ideals, or for want of a better word, of having really strong governance, but also really strong engagement with the community, public, stakeholders, and traditional owners of the Great Barrier Reef. And so that's been at the core of our entire program since the very, very beginning. It's equally important for all of the different ideas, not just marine cloud brightening. Quite interestingly, some of our stakeholder groups or traditional owner groups, for example, due to their cultural beliefs and their connection to their sea country, they might have a bigger problem with moving corals from one place to another than they do with the idea of cloud brightening, for example. And that's just one example, but it's different sectors of the community and stakeholders and traditional owners and other interested parties, I guess, have their own sets of beliefs and concerns and opinions, which are all valid and all have to be integrated. What that looks like then in practice is a very strong governance arrangement. Are working in a federally regulated marine estate. There's a very clear system for permitting. That also does include some requirements of its own for traditional owner invitation to comment. It does also include a step of open public comment on any research proposal in the Great Barrier Reef. And so that's for any permit to do research in the Great Barrier Reef at all. You have to go through that process. On top of that, we've built our own governance arrangement. So we have an independent risk review group. We have a steering committee, a board with independent members, a sort of internal process for risk assessment before any fieldwork can go ahead, of course. So there's quite a few layers there in the governance arrangement, but really we sit at the highest level under this federally regulated system that's very established, really quite advanced in terms of marine estate management, and also includes mechanisms that go even higher than that regulator if you do something on a large enough scale to create a significant risk or potential for a significant impact to biodiversity or sort of ecosystem values, then it triggers an even higher level of federal regulation, which is the same level of regulation that sort of a really major ecosystem altering engineering project or something would be subjected to. That's sort of the governance framework. And then the engagement obviously interacts with that. Our program includes a large cohort of social scientists, also scientists interested in regulatory and governance. And so there's essentially, we've run a program of engagement that the social scientists are constantly designing, evaluating, conducting research on, and improving. So sort of at the same time as we're doing the on the ground engagement, the social scientists are doing research about how can we better improve that and how can we disseminate the learnings to the world. And then on top of all of that, we have the traditional owner engagement program. And so we have a self-imposed rule within the program that we don't do any research out on the Great Barrier Reef on sea country of traditional Indigenous groups that have a historical link of managing that sea country over tens of thousands of years without getting their express permission. So it's a hard and fast rule. If we weren't granted permission, we would either keep trying to seek it or go somewhere else. We've never been refused permission with the Marine Cloud Brightening research, which is nice. But that's not a sort of a one-way process either, right? We go and we meet with the traditional owner groups for where we want to do research, and we explain to them the project. We produce pamphlets so that the wider communities can have the information disseminated to them, not just the sort of leaders of the community, the elders. And then we regularly go back and report after we've done, or as we do, and after we've done experiments, and report on the results and let them know where the research is up to. Another thing that we do is we have these community reference panels, which were being set up and run by the social scientists, where they invite members of the public to form a panel. Each one lasts for 12 months and meets every couple of months over the course of that year. And again, it's for facilitating this two-way discussion where the scientists aren't just telling information to traditional owners or to the general public, but we're actually seeking to incorporate their views and opinions into the research. And it's been immensely beneficial. What us as scientists might think are the biggest risks that need to be addressed for cloud brightening, for example, have often turned out to be very, very different from what the public's actually worried about. And so by having this two-way discourse, we learn about what the community's views are and what their sort of aspirations and concerns for the research are. And then we build that into the research program.
Daniel's team is now wrapping up their first 5-year block of funding and is currently applying to the Australian government for a further 5 years. But let's return to the cancelled experiment we started with. Though the 2024 experiment was called off, the Mayor of Alameda has indicated she would keep an open mind about future projects from the University of Washington team. However, she also expressed concerns about unintended consequences of these types of experiments on the climate and about communication. Here is the Mayor of Alameda, California, Marilyn Ezzy Ashcraft, in an interview in June 2024 with a reporter from KRON4, a local television station in the Bay Area.
In fact, we listen to scientists from all over the world, and 146 countries have asked that these kinds of experiments not be done because of the unintended consequence of then impacting the climate in a negative way for other countries. But we support science, we believe in science, but the scientists have to make a good, credible case too, and in a timely fashion.
As with all SRM ideas, MCB has not been implemented anywhere in the world at a scale that would affect the climate. However, it has been the subject of limited outdoor experiments, spurring controversy in some communities. In future episodes, we'll return to the subject of outdoor experiments and look at proposals for how these experiments should be governed. But that's it for today's episode of Climate Reflections. Thanks for listening. This is a new podcast and we're hoping to build our audience. So if you enjoyed it, please do share it on social media or recommend it to a friend. If you have a question about SRM or just want to find out more, go to our website, SRM360.org, which has been newly revamped. And there we answer questions from the audience in our monthly news roundup, so you might hear your question answered there. You can find a transcript of today's episode with links to sources on our website, so please check it out.